A regular expression, abbreviated to RE, Regex, Regex, and more, is commonly used in software development and searching algorithms for matching patterns in text. They are particularly important for implementing programming languages. Regular expressions are powerful formula for defining patterns to search for, yet they are also very simple. They can be defined with combinations of just 4 symbols: the clean star, shown as an asterisk, alternation, a vertical bar, and the open and closed parentheses. Say we want to search these terms and conditions for important dates. For simplicity, we'll only worry about numerical dates. There are only a few different formats we can expect dates to be in, right? We just search for day, day, month, month, year, year. However, it could be day, day, month, month, year, 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 if you're being formal, or maybe just day, day, month, month, if you don't need the year. But the first month digit can only be 0 or 1, and the first day digit can only be 0 to 3. Sometimes people ignore the 0 if the date is only 1 digit, so it could just be day month. But for other people the month comes before the day, so we have to account for that too. My word, it's all so complicated, isn't it? Thankfully, we can use regular expressions to simplify writing rules for the patterns we want to match. This series of videos explores the idea more closely, looking at the meaning of these basic symbols, some common extended syntax, and the close connection between regular expressions and finite state automata. Let's take a look at how we use the 4 basic symbols in a regular expression, starting with the parentheses. In arithmetic, if we have the equation 1 plus 2 times 3, we follow the order of arithmetic expressions and solve the multiplication first. So we get 1 plus 6, which equals 7. But if we add parentheses around 1 plus 2, it holds the highest precedence, and so we get 3 times 3, which equals 9. In Regex, parentheses work in the same way, specifying the highest precedence. Next we have the clean star, named after the man who helped found the concept of regular expressions. This matches the preceding symbol repeated 0 or more times. For example, BA star will match B and BA and BAA and BAAA, and so on. Lastly, we have the alternation symbol. This can be read as a choice, so the expression A parentheses A bar B parentheses matches both AA and AB. We usually refer to this as bar and read it as OR. Bar has the lowest precedence of the basic regex symbols, so A or B star is the same as saying A or B star, which means you can either match an A or any number of B's. Let's say we want to match every number in a text. Numbers are made up of 1 or more digits concatenated together. Using our basic regex symbols, that would be any digit. 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 concatenated with 0 or more of any digit. 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 star. Now this is far too long for a busy computer scientist. Thankfully, we can use some extended regex syntax to describe this and others using only a few symbols. In many systems, a list of symbols between square brackets, like bracket 0, 1, 2, 3, 4, 5 bracket, means choose one from this list, and we can shorten this further to bracket 0-5 bracket, which means choose any symbol in the range 0 to 5. But in our example, we want any single digit, so we can use another code, \d. \d star is so much shorter now, but it still matches exactly the same pattern. In fact, we can shorten it even more by introducing the plus notation. While A star matches 0 or more A's, A plus matches 1 or more A's. So we can now write our regex formula that will match any number as \d plus. Other common symbols are the question mark, which matches an optional occurrence of the symbol, a number in curly braces, which matches exactly that number of the previous symbol, and the period or full stop, which matches any single character once. Remember, all of these extended regex symbols may be pretty fancy, and they shorten things a lot, but they are really just shortcuts that could be written longhand using the four basic symbols, bar, star, and the parentheses. Finite state automata, explained in an earlier series, describe exactly the same languages as regular expressions. Every regular expression can be converted to a finite state automaton, and every finite state automaton can be expressed as a regular expression. For example, our regular expression for numbers, \d plus, can be converted to this automaton, a non-accepting start state and an accepting state, with two transitions. You may notice that in this automaton there is no transition for anything other than a digit. We could include these other transitions by introducing a trap state, as our regular expression only allows digits in its language. But usually this is left out for simplicity. If a symbol has no transition out of a state, we assume it goes to a trap state, and hence the associated string is not accepted as part of the language. So what's all this about languages? Well, here we are not talking about the usual human languages like the variations of English. We're talking about formal languages, each of which being a set of strings that are accepted by some rule. For example, \d plus produces a language that includes strings like 203, 57, and even 000, but not B17 or -12. Regular expressions and finite state automata describe a very particular type of formal language known as regular languages. These may be one of the most basic formal languages, so they can't describe everything, but they still have a huge number of uses. Variable names, numbers, URLs, email addresses, and phone numbers can all be described by regular languages. Computer scientists find it easier to read regular expressions than finite state automata, but computers are better at following automata, so usually we design an expression, then use a computer program to convert it to an automaton, which is then used as required. Let's take a look at another common example, URLs. Here is a regular expression for URLs I came up with earlier. It isn't perfect. Perhaps by the end of this video you'll have figured out some things that are missing, but it's a good starting example, so let's take a look. Before we do though, we need to make one more clarification. Apart from some cases, such as \d, the backslash is used as an escape character, and so the following symbol is matched as is. We found before that the period matches any single character, but \period matches the period itself. This is the same for \/, as / normally matches the division symbol. So, first we have the Hypertext Transfer Protocol, HTTP, with 0 or 1 of an S, followed by : //. This is the part of the URL you see before the actual web address. This entire sequence can be left out, so it is enclosed in parentheses and followed by a question mark. The next sequence, the main web address, is a combination of characters and symbols. We have a choice between a letter or a digit or a period or a hyphen or a forward slash, but we almost certainly need more than one, so it is wrapped in parentheses and given a plus symbol. After this, there is a period, then the suffix. .com is the most common example, but there are many regional alternatives, such as .co.nz for New Zealand and .co.uk for the United Kingdom. In this series of videos, we took a look at the basic meaning of regular expressions, what they're used for, as well as some of the many different symbols used in practical systems, though they can all be expressed in terms of just for. For more information and examples, check out the Computer Science Field Guide. Regular Expressions is in the chapter on formal languages. Thanks for watching.